Hello everybody, I welcome you all to NK's Geology class. Today I will discuss about the tectonic elements of India, also the physiographic features of India. So let us discuss. India is a country with continental dimension. It is bordered by the great Himalayan mountain chain on the north, the seas on the east, west and south. And geographically it occurs between latitude 6 degree 44 minute north, which is the Indira point in the Nicobar Islands, to 37 degree 6 minute north, and longitude ranges from 68 degree 07 minute east to 97 degree 25 minute east. So in this region, the great Indian landmass that occurs, and tectonically and physiographically it is divided into three major divisions, such as peninsular India, Indo-Gangetic plain and extra-peninsular India. So these are the three prominent and major relief features or the physiographic features of Indian subcontinent. So let us discuss these tectonic units or physiographic units one by one. Peninsular India. So peninsular India is the old, stable, rigid block of Indian shield composed of rock types of Archean and Proterozoic age mostly. Geologically it is divided into cratons and mobile belts. The cratons are Dharwar Craton, Bastar Craton, Singhbhum Craton, Bundelkhand Craton and Aravalli Craton. And the mobile belts are Pandyan Mobile Belt, Satpura Mobile Belt, Eastern Ghat Mobile Belts. So here we have the Aravalli Craton in Rajasthan, we have the Bundelkhand Craton in UP and MP, we have the Singhbhum Craton covering parts of Odisha and Bihar, then this Bastar Craton mostly in MP, Chhattisgarh. Then we have the Dharwar Craton, Western Dharwar Craton and Eastern Dharwar Craton. Besides these cratons, we have the mobile belts such as the Satpura Mobile Belt, this portion, the Eastern Ghat Mobile Belt and the Pandyan Mobile Belt. Pandyan Mobile Belt is separated from the Dharwar Craton by Palghat Kaveri shear zone, and Bastar Craton and the eastern part of Dharwar Craton, they have been separated by the Godavari graben. Similarly, Singhbhum Craton has been separated from Bastar Craton by Mahanadi graben, and the Aravalli Craton and the Bundelkhand Craton, they have been separated by the Satpura Mobile Belt. So these are the cratons and mobile belts of India. So we have these cratons and mobile belts that mostly cover the entire peninsular India. So the above cratons and mobile belts, they are represented through major physiographic features of peninsular India, and they are represented through Western Ghats, the Eastern Ghats, Central Indian Highlands, Deccan Plateaus, Aravalli Range, Assam Plateau, coastal plains and Thar deserts. So entire the peninsular India is represented by the highlands and coastal plains and the Thar deserts. So let us discuss these features one by one. We have the Western Ghats. Western Ghats are otherwise called as the Sahyadris or the Great Indian Escarpment or Great Escarpments of India, because the Western Ghats present very steep slope to the western side. The Western Ghats, they form the mountain ranges between Tapti Valley on the north and Cape Comorin on the south over a length of about 1600 kilometers in north-northwest, south-southeast trend, or we can say it is mostly in north-south trend. The average height of the Western Ghats is around 1000 to 1300 meters, width about 30 to 120 kilometers, and slope very steeply on the western side, and gentle slopes are there on the eastern side. The gentle slope is from west to the east. Therefore, rivers originating from the Western Ghats, they drain towards the east and flow into the Bay of Bengal. Its northern part, that is about 85 to 90% of the Sahyadris, are covered by the Deccan basalts through Deccan volcanism, and the southern part is represented by the Indian shield made up of Archean and Proterozoic rocks. The Western Ghats form a continuous chain of mountains with many gaps such as Palghat Gap, Thalghat Gap, Bhorghat Gap, then Ambaghat Gap, Cholamandi Gap, then Holiala or Kalghat Gap. So these are the major gaps that are found within the Eastern Ghats, which link the west coast with that of the central Indian highlands or the central Indian portions of the Indian subcontinent. So these are the prominent features in the Western Ghats. And if we take into account the mountains that constitute the Western Ghats, they are Saiwan Talsari Hill at the Gujarat border, Salbari Range, Dholbari Range, Timbok Range, Timbok Range is found in Nasik, and Igatpuri Hill, Thalghat region, Mahabaleshwar Hill, Koyana Satara Hill. They are all found in Maharashtra state. So they are the Western Ghat hill ranges in Maharashtra. Similarly, in Karnataka section we have Khanpur Hill, Haliala Hill, Kudremukh Range, Baba Budangiri or Chikmagalur Hill, Agumbe Hill, Wayanad Pass. So these are there in Karnataka portion of the Western Ghats. Similarly, we have the Kerala section where Brahmagiri Range, Nilgiri Hills, actually Nilgiri Hills come at the junction of Tamil Nadu, Kerala and Karnataka. Then the Silent Valley or the Attapadi Hill, Anaimalai Hill, Palani Hills and Kadmam Hills, that is in Kerala region. And the Bharusnath Hill, Augustamalai Hill, they are found in Tamil Nadu section. So these are the major hill ranges of Western Ghats. The highest peak is found in Anaimalai mountain, that is Anaimudi, which is the highest peak, followed by Dodabetta. So, if you take a look at the mountain ranges, these mountain ranges, they begin from the Tapti to Kanyakumari or Cape Comorin in a continuous manner. This is continuous mountain. So, mostly these are represented by the Anaimalai Hills, Kadamam Hills, Nilgiri Hills, then the Sahyadris are made up of these major hills. So, Nilgiri Hill is the junction zone between the Western Ghats and the Eastern Ghats. and they form the part of the Western Ghats. So Western Ghats, they form a continuous chain of mountain in the west coast, and the west coast is very steep. So let us discuss how these Western Ghats came into existence, or the sequence of events that took place in the evolution of Western Ghats. Indian landmass was a part of the southern supercontinent Gondwana land. Rifting of that landmass took place towards the Mesozoic, towards the middle of the Mesozoic. And Indian landmass started rifting from Madagascar during 88 to 80 million years ago with the development of the Mascarene Basin, which is a part of the Indian Ocean, Mascarene Basin. This basin came into being because of rifting of India from Madagascar. After rifting, India drifted towards north, passed over the reunion hotspot. When it was passing over the reunion hotspot, it experienced extensive volcanism, which is recorded as Deccan lavas to constitute Deccan troughs in India, ranging in age from 66 million years to 60 million years. So they produced Deccan troughs through volcanism by a hotspot, that is a reunion hotspot. And the India's western margin got separated from Seychelles, which is a microcontinent in the Indian Ocean, towards the eastern side of the African landmass, and it is towards the north of the Madagascar. And this separation took place about 65 million years ago through a rifting. So Indian mass rifted from Madagascar first, then it rifted from the microcontinent Seychelles towards the north of Madagascar. And in this manner, Indian landmass started moving towards the Eurasian landmass in order to close the Tethys to form the Himalayan chain of mountains. So final phase of uplift of the western margin of the Western Ghats and the Deccan volcanism took place during 65 million years to 60 million years ago. And the volcanism took place in several phases. And accumulation of volcanic material continued, which gave rise to 2 km thick of lava that made the Deccan trough basalts. So the western part of this Indian landmass shows rifting from Madagascar and from that of the Seychelles, because of which the western side is very steep. And because of the Deccan volcanism, the western side has been lifted up. So the slope of the Western Ghats is towards the east. The major rock types of the Western Ghats are the basalts, Deccan basalts, which cover most part of the Western Ghats. And beside these basalts, there are shales and limestones in the intertrappean beds between the lava flows. The basalts contain zeolites, calcites, feldspars, rock crystals, beryls, which show as the vesicular fillings. And the intertrappean beds are found to be highly fossiliferous, containing fossils of mollusca and fishes. So the Western Ghats, they form a prominent feature in the west coast, with most part of the northern part represented by the Deccan volcanics that cover the ancient rocks, and the southern side is represented by the ancient crystalline rocks of Archean and Proterozoic age. And let us discuss about the Eastern Ghats. The Eastern Ghats, they form a discontinuous chain of mountains, whereas the Western Ghats, they form a continuous chain of mountains. And these Eastern Ghats, they have been made discontinuous by the rivers which cut across the Western Ghats and fall into the Bay of Bengal. And the Eastern Ghats, they extend over a length of 1131 kilometers with breadth 100 to 200 kilometers and height about 1 kilometer to 1.5 kilometers. It begins from north of Mahanadi Valley in Odisha up to Nilgiris on the south. It has been made discontinuous by the east flowing rivers such as Mahanadi, Godavari, Krishna and Kaveri. The hills which constitute the Eastern Ghats are the Similpal Hills, Gadjat Hills and Mohendragiri Hills, Mali or Malkanagiri Hills in Odisha, the Koraput Araku region of Western Ghats in Andhra Pradesh zone, Papikonda and Nalamalai Hills, Velikonda Hills, Palkonda Hills, Kondapalli Hills, they are found in Andhra Pradesh region. And in Tamil Nadu region, there are Javadi Hills, Sevara Hills, Kalran Hills, Panchamalai Hills, Kolli Hills, and Sirmalai Hills, with major peak Mohendragiri of Odisha, with Devamali at the highest peak in Odisha. Then Jindagada or Armakonda is the highest peak of Eastern Ghats, having height 1680 meters, located in Godavari Araku hills of Andhra Pradesh. So Eastern Ghats, they represent the hill ranges in Odisha, Andhra Pradesh and Tamil Nadu region. The Eastern Ghats represent high-grade metamorphic rocks that form long arcuate mobile belt. It shows changes in its trend, that is northeast to southwest from Mahanadi Valley to Krishna Valley, then turns south and south-southeast and enters into the sea, bends back again and re-emerges on the land near Madras in west-southwest trend up to Nilgiri. In the north part of Odisha, it shows a trend north-south, and in eastern part, it shows east of southeast, which gets caught up in the coast. The rock type ranges in age from Archean to Proterozoic, with basement rocks between 3 to 2.6 billion years, followed by Proterozoic rocks having age from 1.8 to 0.9 billion years, and late Proterozoic rocks around 1 billion years. The rock types are chondrolites, chernocites, migmatites, granulites, granites, cyanites, alkali granites, anorthosites, quartzites, calc-granulites. So these are the major rock types of Eastern Ghats. These rock types have undergone folding, faulting and uplifting through several phases of deformation. Several phases of deformation. The rift zones which have affected the Eastern Ghat rocks are the Mahanadi rift, through which Mahanadi is flowing, Godavari rift, Godavari is flowing, and there is Eastern Ghat boundary fault. The whole Eastern Ghats form a mobile belt bounded by Singhbhum Craton, Bastar Craton and Dhaular Craton. The mineral resources of this belt includes East Coast bauxite, manganese of Gondiatic and Kodurati type in Odisha, Andhra Pradesh, iron ore in Mayurbhanj, Odisha, Keonjhar belt, the chromites that occur within pyroxenites and anorthosites, in graphites they occur with chondrolites. The evolution of stagnites have taken place out of sediments deposited in continental margin that has undergone compression, subduction and collision between India and Antarctica during Greenvillian orogeny, due to which it has been uplifted to form hill ranges during Rodinia supercontinent cycle about 1 billion years ago. So, the Western Ghats, they represent the highly mineralized zone along with the complex group of rocks starting from granites to granulites, chondrites, charnokites, migmatites, anorthosites, calcgranulites, quartzites, and the age goes up to 1 billion years from the end of Archeans. Now let us discuss about the Central Indian highlands, which form the part of the cratons and part of the mobile belts, including the platform covers. So let us discuss the Central Indian highlands, which include the Malwa Plateau, the Bundelkhand Nishi complex, the Vindhyan range, Satpura mobile belt, Chotnagpur plateau, Assam plateau. So what is the Malwa plateau? It is located between Aravallis on the northwest and Vindhyans on the southeast. So it lies between Aravalli and Vindhyas. It is made up of Deccan basalts in the west and Vindhyan sandstone shell limestones on the eastern side. The sandstone sequence is Proterozoic in age, while the Deccan basalts are Cretaceous Paleogene in age. So this plateau is forming a part of the Central Indian highlands. Similarly, we have the Bundelkhand Nishi complex, which is generally considered as a craton because it forms a stable landmass. It forms a stable crust or craton that lies between Jamuna river and Betwa Dhasan river in the states of UP and MP. On its north, there is Indo-Gangetic plain. On the south, there is Vindhyan basin, Vindhyan group of rocks. The rock types represent Archean age with age greater than 2.5 billion years, and it includes the granitic niches, migmatites, amphibolites, banded iron formation, quartzites, metapolites, gabbro, perotites, comatites, and quartz reefs. The trend of the rock types is northeast southwest. So they form the stable landmass, or they form a craton surrounded by the Satpura mobile belt on the south. So let us discuss about the Vindhyan range. It occurs between Aravalli range on the west and the Kaimur range, Son Valley on the east. So Vindhyans lie between the Aravallis and the Kaimur range. It has the Bundelkhand Nishi complex on its north and Malwa plateau on the south. So the rock types are sedimentary sandstones, shale and limestones of Proterozoic age, because they represent the platform cover. Along the western margin of the Vindhyan group of rocks, there occurs a large reverse fault, which is called as the Great Boundary Fault of Rajasthan, which brings the Aravallis on the western side against the upper Vindhyan rocks such as Bhander sandstone on the eastern side over a length of 800 kilometers. So this reverse faulting has brought the Aravallis with the upper Vindhyan rocks over a length of 800 kilometers. The upper Vindhyan rocks are not affected by earth movements. The lower Vindhyan rocks are intruded by basic lavas and have been disturbed by folding and faulting. So upper Vindhyans are not found to be disturbed. Vindhyans are noted for their economic minerals such as limestone, sandstones, flagstones and phosphorite. So these Vindhyans, they form the platform cover made up of sedimentary sequences that overlap the TECTONIC rocks of the central India. Then let us discuss about Satpura mobile belt. It occurs between Narmada river on the north, Tapti river on the south, Aravalli Malwa plateau on the west and Chhatnagpur plateau on the east. So it forms a long series of mountains starting from Rajpipla hills on the Gujarat through Gailgarh hills in Maharashtra MP border, Mahadev hills, Moikal range in MP Chhattisgarh region. So major rock types, major hill ranges, Rajpipla, Mahadev and Moikal range. The important peaks are Dhupgad or Panchamadi, which is the highest peak in the Satpura region, and the Amarkantak peak, which is the source for Narmada river and Son river. These two rivers, they originate from Amarkantak. The physiography represents highly dissected rugged topography or highly cut dissected topography. The rock types belong to middle Proterozoic in age and represent east-west trend or east of northeast, west of southwest trend, which is the Satpura and Mahadev trend. The basement rocks are Archean gneisses and granulites and are overlain by Deccan basalts of Cretaceous Paleogene age. Narmada Son fault zone has been affected by the rocks of this belt and there has been upliftment of the region along the fault. And the economic minerals that are found in this region include bauxite in Amarkantak hills, manganese in Balghat zone, limestones and dolomites. They occur within the Satpura group of rocks. So Satpuras, they constitute a mobile belt having age Proterozoic and they have been extending from Gujarat to Chhattisgarh in east-west manner and is containing highly deformed rocks. Then let us discuss Chhatnagpur plateau. It occurs between the Gangetic plain on the north, Odisha plateau on the south, Bengal basin on the east and Baghelkhand Moikal region on the west. So from the eastern portion of the Satpura mountains, the Chhatnagpur plateau begins and it extends over Odisha, West Bengal and Chhattisgarh, Bihar, Jharkhand region. It includes the Singhbhum Craton, Ranchi Plateau, Hazaribagh Plateau, Kodarma Palama Plateau, Rajmahal Hills, Parasnath Hills, Damodar Trough, which is coal bearing, and Singhbhum Mayurbhanj region, which is iron ore group. So This region is found to be mineralogically, economically very rich. The rock types belong to Archean and Proterozoic in age. Mostly they belong to Singhbhum Craton and iron ore group of rocks. And also it contains Upper Paleozoic and Mesozoic Gondwana rocks. The rock types are granite niches, schists, banded iron formation, quartzites, intrusive granites, and it forms the mineral heartland of Indian landmass, which is represented by iron ore group of rocks or iron ores extending over Noamundi, Goa, Joda, Bodbil sector, and in parts of Jharkhand, Chhattisgarh, Bihar. Coal deposits occur in Jharia, Bokaro, Ramgarh, Karanpur, Raniganj, in parts of Bihar and Jharkhand. Manganese deposits in Noamundi, Garcila belt, bauxite in Ranchi, Palamau district, Palamau plateau. So the entire Chhattisgarh plateau area representing the Singhbhum Cratons are found to be highly mineral bearing or ore bearing, and it is called the heartland of the mineral heartland of India. We are there. The copper deposits in Musabani, Rakha of Singhbhum, mica in Kodarma mica belt, uranium in Jaduguda mines of Bihar. So these are the economic mineral deposits which are associated with this Chhattisgarh plateau region. Then we have the Assam plateau or the Shillong plateau, which is also called as Meghalaya plateau. So it is the extension of Satpura trend and thus forms the extension of the peninsular plateau. It is separated from the Chhattisgarh plateau by Garo Rajmahal gap. This gap separates the Shillong plateau from that of the Chhattisgarh plateau. It is represented by three hills, Garo, Khasi and Jaintia hills. The rock types show Archean basements such as granite niches, schists with overlying sedimentary formations of sandstone, shale and limestones that represent the sediments of the Himalayan rocks. The whole area is found to be highly affected by faulting. The faults owe the origin to continental collision of India with Eurasian plate. The Assam plateau is actually a host that has been uplifted during Miocene-Pliocene time. It is bordered on all sides by faults. The Disang fault is on the northeast, Naga thrust is on the west. The Disang fault is the easternmost of 8 to 10 thrusts, forming a Suppen zone 20 km wide. The zone of thrust ends abruptly in northeast against the Mizu thrust, which brings the Precambrian Nisic rocks over it. The line of junction runs west of northwest to east of southeast, close to the Dahing river. The Mizu thrust runs northwest across Brahmaputra valley and overrides also the main boundary fault of the eastern Himalayas. The Dauki-Phauki is the dextral transcurrent fault along which the Assam plateau has been moved to east over 250 kilometers. This fault has caused tilting of the plateau northward. So this is the dextral transcurrent fault that has drifted the Assam plateau over a length of 250 kilometers and it has made the plateau tilt northwards. And the Sylhet traps that forms a part of the Assam plateau and it is related to Deccan volcanism. So economically these plateaus are famous for coal, limestone and petroleum. Coal is found in Garo Khasi Jaintia hills, limestone is found in Khasi Jaintia hills, petroleum is found petroleum and gas is found in Digboi region. So, this is another important section of the Indian Peninsula region that has been separated from the central Indian mass by a gap, that is Garo Rajmahal gap, and it represents the host uplifted during the Maya-Pliocene time, and over which we find the sediment deposits of derived from the Himalayas. Then let us discuss the Aravalli range or Aravalli Craton. It is the oldest mountain of India, made up of Precambrian crustal rocks. It extends from Delhi on the north up to Gujarat or Ahmedabad, Palanpur, with core region occurring within the Rajasthan state. The length of this mountain is over 700 kilometers with width 10 to 100 kilometers, height 300 to 900 meters, and highest peak is its Guru Shikhar, that is Mount Abu. And the basement rocks are represented by Archean and Paleoproterozoic rocks with age from 2.5 billion years to 3.3 billion years. It is the folded belt, and the folding took place through a major orogenic event between 2 to 1.8 billion years ago. Rock types strike northeast southwest with varieties such as TTG group of rocks, granite niches, and they are overlain by quartzite, phyllite, schist, dolomites, limestones, banded iron formation, marble, and metamorphic grades between green schist to amphibolite facies. The rock types have undergone multiple phases of deformation, D1, D2, D3, and with tectonic lineament represented by great boundary fault that separates the Aravallis from the Vindhyan rocks. The mineral resources include lead, zinc, and silver in Jawar belt, copper in Khetri belt, iron in Alwar belt, phosphate in Udaipur region, marble in Mekrana region of Rajasthan. Its tectonic evolution includes cratonization of the basement with rift basin sedimentation followed by Paleoproterozoic orogeny leading to formation of fold mountains in Aravallis. So Aravallis, they form a craton, and it is found to contain a lot of mineral deposits, base metals, lead, zinc, copper. Also there is silver deposit, phosphate, and it is noted for the marbles, Mekrana marble. And the rock types belong to Archean in age, the oldest mountain of India. Then let us discuss about the Deccan Plateau, which covers the cratons such as Dharar Craton and the Pandyan Mobile Belt, including the plateaus of the central India. So Deccan Plateau, it is a large elevated triangular landmass in peninsular India, mostly composed of Deccan trap basalts and ancient crystalline cratonic rocks that slope eastward from the Western Ghats to Eastern Ghats. It occurs south of river Narmada and is bounded by Western Ghats on the west, Eastern Ghats on the east, Satpuras on the north, and the granulate terrain in the south, that is the Pandyan Mobile Belt. Following are the major plateaus of the Deccan province. In Maharashtra region, there are basaltic rocks which represent the Deccan traps. In Karnataka region, it includes the Malnad highlands, the Moidan plains composed of granulatic niches. In Telangana region, it is represented by residual hills of granitic niches. In Rayalaseema plateau, it is made up of hard crystalline rocks and gneisses. Major part of the Deccan traps are covered by Deccan basalts, which form the igneous province or trap. The basaltic lavas got erupted in several phases over a range of 30,000 years in each phase, covering 5 lakh square kilometers exposed area with a maximum height of about 2 kilometers. The eruption took place on the western coast around 65 to 60 million years ago through volcanism at Reunion hotspot, and the basalts are highly vesicular and contain minerals like beryl, amethyst, rock crystal, calcite, feldspar, zeolites that fill the vesicles. The major event that took place during Cretaceous-Paleogene junction is the impact of asteroid at Mexico, known as Chicxulub impact in Yucatan Peninsula, Mexico, or this is known as potassium KPG mass extinction, during which 75% of Earth's species became extinct. It is Cretaceous Paleogene mass extinction, KPG, Cretaceous Paleogene mass extinction, during which 75% of Earth's species became extinct. It includes the non-avian dinosaurs, ammonites, belemnites, marine reptiles, TECTONIC foraminifers, which were caused due to release of sulfur dioxide, carbon dioxide from the massive basaltic eruptions, leading to acidification of the oceans, darkness enveloping the earth for a pretty long time, and collapse of photosynthesis during the Deccan volcanism 66 million years ago. And this led to stop in photosynthesis, so the herbivores became extinct. The acidification of the oceans caused large-scale extinction of marine fauna. Besides these igneous provinces on the north and west of the Deccan province, there are other areas of Deccan plateaus which are represented by western Dharwar Craton and eastern Dharwar Craton, separated by each other through Chitradurga shear zone, and the southern granulate terrain. The age of the rock types is Archean, 3.6 to 2.5 billion years, and the varieties are TTG, shoot of rocks, oldest metamorphic groups, volcano-sedimentary sequence such as comatite, basalts, grey-wax, and banded area formation, close-pared granite with trend of rocks north-south and northwest-southwest. Grade of metamorphism increases eastwards. Contact metamorphism occurs at the contact with the granite protons. Economically, the area is noted for gold, iron ore, manganese, chromite, base metals, limestones, diamond. So it is another economically rich zone in the southern India, and they form a major relief feature of Indian subcontinent, represented by the Archeans, Proterozoic rocks, and the Deccan basalts. Now let us discuss about the coastal plains. These plains are divided into East Coast Plains and West Coast Plains. East Coast Plains and West Coast Plains. In East Coast, they lie between Eastern Ghats and the Bay of Bengal, over a length of about 1500 kilometers, with width varying from 30 to 120 kilometers, from Subarnarekha river on the Odisha West Bengal border to Kanyakumari on the south. It includes plains of Odisha from Subarnarekha to Rishikulla, Andhra Pradesh from Krishna to Godavari, and in Tamil Nadu it extends from Pulicat Lake to Kanyakumari. The rock types are alluvial deposits made up of major rivers and they are very recent in age, Cenozoic rocks. They are the sedimentary plains or the coastal plains are Cenozoic in age. Similar the western coast, it stretches from Gujarat to Kanyakumari between Western Ghats and the Arabian Sea. The length of the plains is between 1500 to 1600 kilometers, with average width 50 to 80 kilometers. Maximum width is about 100 to 120 kilometers in parts of Gujarat and northern Konkan. It is made up of Kutch coast, which is marshy, Kathiawar coast, which is rocky, Gulf of Kutch and Khambat, which are there in Gujarat, the Konkan coast in Goa, Karnataka coast from Goa to Mangalore, and Kerala or Malabar coast, which is the southern part of the west coast plains. No deltaic environment exists in the west coast, but in east coast there is deltaic environment. And west coast is represented by estuarine condition, which is not there, which is not mostly found in east coast. And east coast is, because the sea coast is gentle sloping, that's why it has favored the formation of the deltas in the east coast. And no such delta is possible in the west coast because the west coast is very steep and the sea coast is very steep. It is not presenting a gentle slope so that the sediments can accumulate and give rise to the deltas. The sediments dumped by the rivers draining into the west coast are easily washed away by the waves, and therefore there is no chance of formation of any delta at the river mouth for the rivers that drain into the west coast or to the Arabian Sea. Then we have another major feature in the peninsular India is the Thar Desert. It occurs on the western side of the Aravallis in the state of Rajasthan and extends between the Ran of Kutch on the south, Punjab plain on the north, and plains of river Indus on the west. So it is demarcated by, it is separated by the Aravallis, the Aravalli mountains, which blocks the rain-bearing wind to pass into this region and cause rainfall. Therefore, rainfall is very scanty over this region because this third portion lies on the western side of the Aravallis. So the desert has developed. Besides this monsoonal scanty rain, there are other reasons for formation of desert because there is drying of the ancient Saraswati Hakra river system due to tectonic uplift. This river has been dead. And there is quaternary aridification with temperature going up to 40 to 50 degrees centigrade in this region, particularly in summer, with 0 to 5 degrees centigrade in winter. That's why, because of this quaternary aridification, because of the orientation of the Aravallis, because of the drying of this Saraswati Hakra river, the entire region has become sandy without any rainfall. That's why it forms a desertic condition. Sand dunes cover 40% of the area with different types of dunes, burchons, longitudinal dunes, parabolic dunes, interdunal plains are there, which are called dhriyan or bhui. Playa lakes called dhans, which are salty lakes, Sambar, Didwana, Lunkar Ansar, and the initial bars of the rocky outcrops are found at Nagaur, Jodhpur and Jaisalmer. Economical, the area is famous for gypsum salts. Indira Gandhi Canal, Rajasthan, or Rajasthan Canal is the source of supply of water to this thirsty region of deserts. So, on the west coast, in the northern part, on the western side of the Aravallis, the condition for formation of subtropical deserts have favored the growth of the desert. Now, we will discuss about the another major relief feature of India, that is Indo-Gangetic Plain, which lies between the Himalayas on the north and the Indian Peninsula on the south. It is the vast plain that extends from Punjab plain on the west to the Brahmaputra valley on the east over a length of about 3200 kilometers with width 150 to 300 kilometers, and that lies between the Himalayas on the north and BGC, Benton DC complex, and Bindan range on the south. It is made out of sedimentary alluvial deposits of rivers such as Indus, Ganges and Brahmaputra. This plain has been longitudinally divided into Brahmaputra plain, Ganga plain and Punjab Haryana plain, and transversely into Bhabar, Tarai, Bhangar which is older alluvium, and Khadar, which is newer alluvium from north to south. And this Brahmaputra region, Ganga plain and Punjab Haryana plain, they are from east to west. And this Tarai, Bhabar, Tarai, Bangar and Khadar, they are the portions of this plain from north to south. The entire plain represents the foreland basin which developed due to downward spring of the northern portion of Indian plate during continental plate collision between India and Eurasia. So this is the fourth deep region in which the sediments has been deposited derived from the rising Himalayan mountains. This basin becomes the site for sedimentation by the Himalayan river system. The basement rocks are therefore Precambrian in origin and they have been overlain by Sialic molasse deposits. Pleistocene older alluvium, that is Bangar, and the Holocene unconsolidated sediments and younger alluvium, which is Khadar. The thickness of sedimentary cover varies from north to south, with very high thickness in the north about 5 to 6 kilometers, medium thickness in the central region, that is 2 to 3 kilometers, and very thin on the south, which is about 500 to 1 kilometers, 500 meters to 1 kilometer. The whole basin is structurally controlled by subsurface ridges such as Delhi Haridwar Ridge, supposed to be the extension of northeast southwest trending Delhi origin, Faizabad Ridge, which is the extension of Bundelkhand Craton, Mangir Saharsa Ridge, which divide the entire plain into these three ridges that divide the entire plain into four shelves, such as Punjab shelf by Delhi Haridwar Ridge, western Uttar Pradesh shelf, which is Faizabad Ridge, eastern Uttar Pradesh shelf is Mangir Saharsa Ridge, and the West Bengal shelf on the extreme west. So the three ridges, they divide the entire Indo-Gangetic plain into four shelves. This extensive plain represents the richest groundwater province of India. Then we will discuss about the extrapeninsular region. It is represented by the Himalayan chain of mountains which stand on as a barrier on the northern frontier of India. It extends over a length of about 2500 kilometers from east to west, that is from Mismi river on the east to Pamir on the west, or that is beyond Karakoram range. This mountain chain is arcuate in shape with convexity towards the south. The width of the mountain ranges varies from 150 to 400 kilometers. There are 14 major peaks with height more than 8 kilometers. The northern region of this mountainous belt extends into the Tibetan plateau and the southern boundary merges with the Indo-Gangetic plain. And longitudinally, it is divided into four zones: Tibetan zone, Greater Himalayan zone or Himadri zone, Lesser Himalayan zone or Middle Himalayan zone or Himachal zone, and the Outer Himalayas or Siwalik zone. Also, it is transversely divided into Punjab Himalayas, Kumaon Garal Himalayas, Nepal Himalayas, Assam Himalayas, because of the rivers which got through them. Tethian, let us discuss the Tethian zone. It is represented by the Karakoram range, Ladakh range, Janskar range and Kailash range. The height varies from 3.6 to 4.2 kilometers and width varies from 35 to 40 kilometers. So it is the Tethian zone towards the extreme north. The landscape of the entire area is barren and desert-like. It is very cold country. It shows Siachen glacier and some other glaciers. And Siachen glacier is the major glacier in this region. The area has been evolved from the Paleo Sea, that is Tethys, which has been closed because of the collision of Indian plate with Eurasian plate. The marine sediments of the Tethys Sea have been compressed and upheaved to form the mountains or highlands of this Tethian zone. The rock types include the sandstone, shale and limestones, and there has been intrusion of granite batholiths in the Ladakh region, and ophiolites have been produced due to suturing of the two plates, Indian plate and Eurasian plate, and the suturing has given rise to Indo-Sangpo suture zone. The strata are highly fossiliferous and ammonitic in this Tethian zone, and the entire marine succession belongs to the Paleozoic to Mesozoic rocks that lie unconformably over the Precambrian basement. So basement is Precambrian. The suturing of the two plates are produced Indo-Sangpo suture zone, ITSZ, which show a syntaxial bend on the east, that is the at Namcha Barwa, and on the west that is Nanga Parbat, Indus Gorge. So syntaxial band is shown by this suture line because of the bending of the Himalayas, syntaxial bending. So this is the Himalayan zone. Here there is bending, Namcha Boru area. Here this is the Nanga Parbat area, bending. So entire, this is the Indo-Sangpo suture zone, ITSZ. And towards the north, here the northern portion is the Tethyan zone. To the south, there is the Greater Himalaya. This is the Greater Himalayan zone. This is Greater Himalayan zone, Lesser Himalayan zone. Then we have the Shivaliks. This is the Shivalik zone. So Greater Himalaya, it is the highest and most continuous range of mountains with height about 6 kilometers and width about 25 to 30 kilometers. The height of the peaks of the world, the highest peaks of the world are found in these regions such as Mount Everest, Kanchenjunga, Dhaulagiri, Nanda Devi, Nanga Parbat, Annapurna. They are located in this region. So this, because this is the zone of Himalayas which form the highest mountains. So it contains the highest peaks. Major gorges that occur in this zone such as Indus Gorge, Satluj Gorge, Tista Gorge, these gorges are there in this zone. The glaciers which clad this region are the Siachen Glacier, Gangotri Glacier, Jamunotri Glacier and Jammu Glacier. The rock types are granitic niches that constitute the central crystalline axis with the schist and tertiary granitic intrusives. There has been thrusting, metamorphism and inversion of topography. In the north of this zone there is Indo-Sangpo suture zone, and on the south it is demarcated by the main central thrust MCT. The evolution of Himalayas took place from the early Eocene, that is from 55 million years to 55 million years ago, and continued up to the Quaternary with basement rocks represented by the Precambrian to Paleozoic rocks. To the south of the central Himalayan zone or the Himadri, that is Himachal or the Lesser Himalayas, it lies south of the Greater Himalayas and forms the middle range of the mountains with height 1.5 to 4.5 kilometers with width 60 to 80 kilometers. There are steep slopes, deep valleys and rough topography. It comprises of Ratanpur range, Pirpanjal range and Dhauldhar range, Mussoorie range, Nagtibba range, Mahabharata range, which is in Nepal. So these are the major ranges that constitute the Lesser Himalayas. The Nagtibba peak separates the Jamuna watershed from Ganga watershed. The hill stations such as Mussoorie, Dhanaulti, Shimla, Nainital, Darjeeling are all located in this region in the Lesser Himalayan zone. The intermittent valleys or dunes or duns between the Lesser Himalayas and the southern Shivaliks are Dehradun, Kutli Dun, Patli Dun, Kangra and Kullu valleys. So these are the planar lands that occur within the hill ranges, hill masses. The rock types of this zone are sedimentary sandstone, shale limestone, siltstone, metamorphic slate, phyllite, schist, quartzites, igneous granites. These rock types have been highly deformed and disturbed because of the two faulted zones, one on the north, the other on the south. On the north there is MCT, main central thrust, and on the south there is MBT, main boundary thrust. These two thrust zones, they have highly displaced the rock types of this entire Lesser Himalayas, and there has been reversal of stratigraphy, as a result of which Precambrian rocks are found to overlap younger rock succession up to Cenozoic. The multiple thrust slices show imbricate structure, nappe, klippe, window structure. This zone is rich with respect to occurrence of limestone, dolomite, gypsum, slate, copper, lead, zinc and graphite. The upheaval of Lesser Himalayas took place with the initiation of uplift during the late Eocene Oligocene time, with uplifting continuing continuing up to the Quaternary. It is still today the Himalayas have not achieved complete isocity. Still the rise of the Himalayas is continuing. The older Himalayas, the outer Himalayas, that is Shivaliks. It forms the youngest and southernmost part of the Himalayas that runs parallel to the main Himalayan range over a length of 2400 km with width 110 to 50 km. And the narrower end is found towards the east and the broader end towards the west. The height of the Shivaliks ranges from 600 meters to 1500 meters and occasionally it goes up to 2000 meters. The Kariwas, which are the lacustrine fluvial deposit that is found in Kashmir, they form a major plains of this outer Himalayas, and the rock types of the outer Himalayas are sedimentary in origin, alluvial deposits such as sandstones, conglomerates, shale, mudstone and morass sediments which are derived from the rising Himalayan ranges and deposited in the continental environment. And these are highly fossiliferous, mostly they contain fauna which are noted as Shivalik fauna such as elephants, hipparian horses, rhinoceros, hominoids. Its southern boundary is represented by Himalayan frontal thrust HFT, that is with the Indo-Gangetic plain that lies to the south of the Shivaliks. The age of the Himalayan rocks is Upper Cenozoic to Quaternary. The evolution of Himalayas is continuing till the present day. And if you take into account the transfer structure of the Himalayas, they are divided into 4 zones by the rivers. Satluj and Indus constitute the Punjab Himalayas, separate the Punjab Himalayas. Satluj and Kali, they separate the Kumaon Himalayas. Kali and Tista, they separate the Nepal Himalayas. And Tista and Brahmaputra, they separate the Assam Himalayas. So these are the 4 zones that have been separated by these rivers: Satluj, Indus, Kali and Tista and Brahmaputra. These are the 5 rivers which have divided the entire Himalayan zone into 4 units. Each of these 4 zones are distinct with respect to the lithology, structure, thrust character and metamorphic grade and relief. Hence, the classification on transverse manner is dealt in addition to the longitudinal classification of the Himalayas based on the thrust zones. So, besides these, we have the oceanic islands in Indian subcontinent. We have the oceans. Oceans are represented by the 2 chain of islands. One is on the east, that is Andaman Nicobar Islands. The other is on the west, that is the Lakshadweep Islands. So these 2 major group of islands, they are the part of Indian subcontinent. So Andamans, they lie in the Bay of Bengal in a narrow arc shaped. They are arc shaped. They are made up of small islands which are more than 200 in number, and they constitute the Andaman Nicobar Islands, and they are supposed to be the extension of Arakan Ema mountains of the eastern Himalayas. So Arakan Ema from the eastern part of the Himalayan chain of mountains which cover the Manipur, Mizoram states, including Arunachal Pradesh. So they have developed due to subduction of Indian plate below the Burmese plate. The ophelites indicate subduction mechanism leading to formation of these islands. The Andamans are classified as North Andaman, Middle Andaman, South Andaman and Little Andamans, which are separated by this Little Andaman, which is separated by the Duncan Passage. So Duncan Passage separates the Little Andaman from South Andaman, and there are 2 volcanoes which are present in the Andamans. They are Barren Island, which is active volcano, and the Narcondam Island, which is the extinct volcano. Narcondam is the extinct volcano. Barren Island is the active volcano. So these are the 2 volcanic islands which are found in Indian landmass, and they lie in the Andamans only. The coral reefs, they fringe these islands. The Nicobar Islands, they are made up of 19 small islands, and they occur to the south of the Andamans and are separated from the Andamans by 10-degree north channel, 10-degree channel. or 10 degree north latitude line which separates the Andamans from Nicobar Islands. The Andamans extend north-south for 350 kilometers and similarly Nicobar Islands extends for 350 kilometers in north-south direction. The southernmost point of the Nicobar Islands is called as Indira Point. The rock types of Andaman Nicobar Islands are limestones, ophiolites and sedimentary rocks that owe the origin to tectonic movement, deformation, sedimentation, and it is linked to the subduction of the Indian plate below the Burmese plate. And on the west coast, we have the Lakshadweep Islands. It occurs in the Arabian Sea of the Kerala coast. It is made up of 36 islands, out of which 10 are found to be inhabited by humans. It represents the coral islands that develop on the top of the volcanic islands, which are the parts of Chagos Lakshadweep Ridge. These islands extend up to Maldives. The islands are divided into Amindivi Island on the north, Lakshadweep Island on the middle, and Minicoy Islands in the south, and they are linked to the Maldives. Atolls, coral reefs, fringing reefs, sand cays are common to these islands. And the 9-degree channel separates the Minicoy Islands from the rest of Lakshadweep Islands. 8-degree channel that occurs within the Lakshadweep group that separates Lakshadweep from rest of the islands. Sombrero channel separates Great Nicobar from Little Nicobar. Preparis channel that separates Andamans from Coco Islands of Myanmar. So these are some of the breaks. These are some of the channels that separate the islands. So this is all about the major relief features of the earth, major relief features of Indian subcontinent, and we have the three major units: the Himalayan extra-peninsular region, the Indo-Gangetic plain, and the peninsular region, including the islands of the Indian subcontinent that occur in Bay of Bengal and the Arabian Sea. And the most part of the Indian landmass is represented by the Archean and Precambrian rocks along with Paleozoic rocks that constitute the peninsular India, with sedimentary rocks forming the part of the Indo-Gangetic plain and Cenozoic rocks that form the Himalayan chain of mountains. So all the mountains, they have been displayed by this map. The mountains of the Himalayas, the mountains of the Aravallis, Eastern Ghats, Western Ghats, the Vindhyan mountains, the Satpura mountains. So these are the major mountains, and so this is all about the tectonic elements and physiographic elements of Indian subcontinent, and I think I have covered all the major features all major tectonic features that are there in Indian subcontinent, and I thank you all for your patient hearing.